testing of sequential circuit that is called as a built-in self-test, that is BEAST. Okay. Now what is BEAST? BEAST means it has the self-test capability. Okay, built-in self-test capability, and that is why we call it as a built-in self-test. Okay. Now this circuit has its own test vector generator. So whatever we are generating a टेस्ट वेक्टर, म्हणजे प्रत्येक सर्किट जेव्हा आपण टेस्ट करतो तर त्याला काहीतरी टेस्टिंग इनपुट द्यावं लागतं. ओके. आणि ते आपल्याला रॅन्डमली आपण एकतर रॅन्डम टेस्ट म्हणजे तिथे रॅन्डमली आपण एखादा डिसाइड करतो की ओके सो वी विल गिव्ह दिस इनपुट अँड देन डिपेंडिंग ऑन दॅट वी आर डिसाइडिंग for that particular input what should be actual output and what we are getting it right now. So comparing that we are deciding whether the circuit is faulty or not. Okay. But here in a built-in self-test, we have this inbuilt test vector generator. Okay, that means this vector generator that itself generates these bit vectors, these test vectors. Okay, so there is this circuitry which defines or which has the linear feedback shift resistor, which is the circuit which generates a test vectors. Okay, so this circuit is also called as a pseudo random binary sequence generator. So it is randomly generating certain binary sequence, and so here this is one example for this linear feedback shift resistor, that is LFSR. This is the abbreviation that is used for this shift resistor. That is nothing but again a test vector generator. Okay. Now what it does, it has a 4-bit shift resistor and there is a feedback through the XOR gate to this shift resistor. Okay, so here you can see this XOR gate where input to this XOR gate is one is the X3 and another one that is X0. Okay, and then that is the input to this first flip flop in this shift register, and then all these are the serially connected. So which type of shift register is this? कुठलं कॉन्फिगरेशन वापरलं याच्यामध्ये शिफ्ट रजिस्टर मध्ये फॉर लुकिंग ॲट दिस सर्किट?
Serial in parallel out.
Yes, it is a serial in parallel out shift register. That means data will come in serially and it will be taken out parallelly. Okay, so here you can see that there are 4 outputs, that is a X3, X2, X0 and X1 and X0. These are the 4 outputs. Okay, now suppose that we have set this shift register earlier so as to get a test vector किंवा इथे जे आपल्याला आउटपुट मिळणार आहे ते काय मिळणार आहे 1 0 0 0. Okay, so that means these outputs we will have as a 1 0 0 0. So for this pattern we have set this shift register. Okay, पहिल्यांदा आपण काय केलं 1 0 0 0 येईल असं सेट केला आणि त्याच्यानंतर आपण काय करणार आहे की आपण प्रत्येक क्लॉक सायकलला याचं आउटपुट काय येतं ते चेक करणार. ठीक आहे, आता माझं जर आता शिफ्ट रेजिस्टर मध्ये प्रत्येक क्लॉक सिग्नलला काय होणार किंवा रायझिंग एज असेल किंवा फॉलिंग एज असेल डिपेंडिंग ऑन द ऍक्टिव्ह लो इनपुट फॉर द क्लॉक और ऍक्टिव्ह हाय इनपुट. तिथे आउटपुटची व्हॅल्यू चेंज होणार आहे डिपेंडिंग ऑन द इनपुट. म्हणजे डी ला जे काही इनपुट असेल त्याच्याप्रमाणे तुमचं क्यू चेंज होणार आहे. So माझं पहिलं सेटिंग काय आहे 1 0 0 0. This is a one example I have taken. So now with the first clock signal what will happen, this one will be shifted to X2. कारण इथं माझा X3 होतला 1 होतं म्हणजे ते आता काय होणार आहे पहिल्या क्लॉक सिग्नलला ते X2 ला जाणार आहे बिकॉज वी हॅव अगेन गिवन अ सेम क्लॉक टू ऑल दीज फ्लिप फ्लॉप्स. So my first X3 bit that will be shifted to X2, X2 will be shifted to X1 and X1 will be shifted to X0. Okay, now X0 will be given as an input to this XOR gate. At the same time X3 will be given as another input to this XOR gate. So whatever is XOR gate's output, that will be input to this D. Okay, so that means that will be nothing but F. Okay, so here whenever I am applying the first clock cycle, now X2 will become as a 1, X1 will become as a 0 and X0 will become as a 0, कारण हे सगळे बिट्स काय होतील, शिफ्ट होतील. आता त्याच्यानंतर X0 हे काय आहे, 0 आहे आणि X3 1 आहे, म्हणजेच काय होणार आहे, F किती होईल, 1 असणार आहे. ओके, बिकॉज 0 1, so F will be equal to 1 and that is why X3 will become as or it will remain as 1 only. Okay, so we will get a pattern that is 1 1 0 0. Okay, in the next cycle now X3 will be shifted to X2, म्हणजे X2 1 होईल, X2 will be shifted to X1, म्हणजे X1 पण 1 होणार आहे आता या सायकल मध्ये, आणि X1 will be shifted to X0, so it will remain as a 0 only. But now this 0 will be given to XOR gate. Also X3 is 1, so 0 1, so here it will be 1 and that is why X3 will become as a 1. Okay, and that is why the pattern we will get is a 1 1 0 0, and here F we are getting as a 1, so that is a X 1 1 0 0 1 1 1 0. त्याच्या नंतरच्या सायकलला काय होणार आहे, X3 will be shifted to X2, म्हणजे X2 1 होईल, X2 will be shifted to X1, म्हणजे X1 1 होणार आहे, X1 will be shifted to X0, म्हणजे आता X0 पण 1 होणार आहे आणि X0 1 आहे, X3 1 आहे, म्हणजेच काय होणार, इथे इनपुट का याचा आउटपुट काय येणार आहे, 0 येणार, म्हणजे F काय होणार, 0 होणार. ओके, so in the next clock signal now X3 will become as a 0, then X2 will become as a 1, X1 will become as a 1 and X0 that will become as a 1. So now again here this is a 0, now in this next cycle here it will 0, so 0 0 that will, sorry, this is a 1, so 1 0 that will become F that is equal to 1. So now in the next clock signal F3 will become as a 1. So in that way there will be shifting of these bits and then we will get different test vectors at or different patterns at this output from X3 to X0, म्हणजे आपल्याला इथे वेगवेगळे पॅटर्न्स मिळतील. सो आपण जर इथला पहिला पॅटर्न जर वेगळा शिफ्ट केला तर अजून वेगळे काहीतरी पॅटर्न्स मिळतील. सो माय क्वेश्चन वॉज दॅट की मी जर इथे 0 0 0 0 सेट केलं पहिल्यांदा, मला आउटपुट काय मिळेल, व्हॉट विल बी माय आउटपुट, जस्ट लिसन, आर यू गेटिंग मी. आता इथे X3 0 आहे, X2 0 आहे, X1 पण 0 आहे आणि X0 पण 0 आहे. तर मी जर क्लॉक दिला तर काय होणार आहे, X3 X2 ला शिफ्ट होणार आहे, म्हणजे X2 0 होणार आहे, X1 पण 0 होणार आहे कारण X2 0 आहे, X0 0 होईल कारण X1 0 आहे. सो हे जे काही बिट्स आहेत ते शिफ्ट होतील. आता X0 0 आहे, X3 0 आहे, म्हणजे इथं काय असणार आहे, 1 असेल. ओके, so now here, but for this whenever we are applying a 0 0 0 0, that time this shift register that will get locked because each and every here bit that is a 0 0. okay, now here actually इथे 0 आहे, इथे 0 आहे, म्हणजे इकडे पण 0 मिळणार आहे, म्हणजे F 0 राहणार आहे आणि मग तुम्हाला इथे परत काय होणार आहे, 0च मिळणार आहे. So this circuit will get locked and that is why you cannot apply the pattern that is a 0 0 0 0 as a input to this circuit. Okay, but as this is randomly generating a binary sequence, so this circuit is called as a pseudo random binary sequence generator. Okay, itself it is generating these different sequences, and that is why it is called as a pseudo random binary sequence generator. Now this is the representative of this linear feedback shift register. You can have different circuitry also. So that means uh, uh, this arrangement can be done differently for this shift register. So, but this is just a simple circuitry for this linear feedback shift register. Now, here, that means that whenever we are using the feedback from various stages of n-bit shift register which are connected to the first stage by means of XOR gates, then we are getting 2 raised to n minus 1 possible patterns for this sequence. Okay, and it has the characteristic of randomly generated numbers. Okay, so this is about the how we can generate different test vectors to which can be used to test a given circuit. Okay, now whenever we are producing these different test vectors, now it is needed that we should compress these sequences. Okay, because there are so many vectors that are generated, and actually uh, that we are applying to the circuit under test. Okay, but these, if we have these many, okay, now here for this example you can see that these many sequences that we have. Okay, याच्यापेक्षा पण अजून तुम्हाला कंटिन्युअसली तुमच्या प्रत्येक क्लॉक सिग्नलला वेगळा सिक्वेन्स मिळणार आहे. So there will be large number of sequences, and that is why we need to compress this patterns. Okay, and so for this we have one circuitry that is called as a compressor circuit. Okay, now depending on how many inputs are there for this compressor circuitry. Okay, that means actually the circuit under test has how many outputs. Depending on that, we need to use uh, two types of compressor circuit. It may be a single input compressor circuit, or it may be multiple input compressor circuit. Okay, so let us first discuss about this single input compressor circuit. That means it has the single output, okay, which is also called as a SIC. So here you can see that this circuit which has a single input. Now here input P for this circuitry is nothing but the output of circuit under test. Okay, so that is applied to the XOR gate as a one of the input to XOR gate, and you can see that remaining circuit is same as that of the earlier circuit that we discussed. That means it is nothing but a pseudo random binary sequence generator, or we can say that it is nothing but a linear feedback shift register. So that is the same circuitry that we have, and then we have one more input to this circuitry, that is a input P, which is nothing but the output of circuit under test. So whenever we are applying a number of test vectors, the resulting values of P that will drive this circuitry, that is SIC, and which is coupled with the LFSR, it produces again a 4-bit pattern. Okay, so here you can see that it will produce a 4-bit pattern. So this pattern generated by this circuitry, that is a single input compressor circuitry, that is called as a signature of the tested circuit for given sequence of tests. That means actually in this circuitry, what is happening in the earlier circuitry, whatever test patterns that are generated, depending on that, circuit under test will get some output. Okay, and that output is given to the SIC in connection with this PRBSG, that is the pseudo random binary sequence generator. And because of this, we will get certain pattern at the output, and that is called as a signature of this circuit. So this signature represents a single pattern that may be interpreted as a result of all the applied tests. Okay. So whatever test that we are applying, depending on that, we are getting a single pattern, and that is called as a signature. So this can be compared against a predetermined pattern. So whatever predetermined pattern that we have, so this can be compared with that, and then we can check whether this circuit that is working properly or not. So for that purpose, this circuit can be used. So this is a single input compressor circuitry. Now here, this circuit provides a good coverage of patterns that may result from the faulty circuit. So whatever results of the faulty circuits that are present, so depending on that, again it will produce certain signature, and we can compare it with the earlier correct signature pattern, and then we can decide whether the circuit is faulty or not. So for that purpose, we are using this single input compressor circuit. Now, if suppose the circuit has the multiple inputs, then we have this type of arrangement. Okay. So here, if now you can see the modification in the circuit. So what modification is done in the circuit? Here, these are the different inputs. So let us say that the circuit has 4 inputs, that is a P0, P1, P2 and P3. These are the 4 inputs. So for each of the flip-flop, we can add a XOR gate, and through that we can give a input. Okay, and then again a 4-bit signature that can be generated. So this 4-bit signature that provides good mechanism for distinguishing among different sequences of 4-bit patterns that may appear on the inputs of this multiple input compressor circuit, which is also called as a MIC. ओके. सो आता इथे काय होणार आहे, म्हणजे आता आपण समजा माझ्या सर्किटमध्ये एकापेक्षा जास्त इनपुट आहेत, म्हणजे माझ्या सर्किटमध्ये सपोज 4 इनपुट्स आहेत, तर मी काय करणार आहे, प्रत्येक फ्लिपफ्लॉपच्या आउटपुटला एक एक्सऑर गेट कनेक्ट करेन, की तिथे त्या एक्सऑर गेटला दुसरं इनपुट काय असणार आहे, तर इनपुट आउटपुट ऑफ दॅट टेस्टिंग सर्किट. ओके. सो सर्किट अंडर टेस्टचं जे काही आउटपुट आहे ते प्रत्येक ठिकाणी इथे कनेक्ट होईल, अँड डिपेंडिंग ऑन दॅट test patterns can be generated, which is called as a signature. Now here, so here we have a different patterns for each of the input pattern. So this is the circuit which is used in a built-in self-test. So if it has the multiple input, we can have this circuit, and for the सिंगल इनपुट वी कॅन हॅव दिस सर्किट. आता इथे जर तुम्ही बघितलं, म्हणजे कंपॅरिझन केलं दोन्ही मध्ये, तर इथे आपण डायरेक्टली कनेक्ट केलाय आउटपुट ऑफ वन सर्किट टू द इनपुट, आउटपुट ऑफ वन फ्लिप फ्लॉप टू द इनपुट ऑफ अनदर फ्लिप फ्लॉप. But in a MIC, we have used this XOR gate in between. Okay? And then we have generated the pattern. So this is a multiple input compressor circuit. So now let us see the complete built-in self-test scheme, which is used for the sequential circuit. So that is implemented as shown in here. Okay. So here the scan path approach that is used to provide a testable circuit. Okay. So that scan path, okay, that method that we have discussed earlier, that is used over here. So that is normally applied on so the test patterns that are applied on this primary inputs, that is W1, W, which is have maybe of n bit, so it may be W1 to Wn, and that are generated internally as the patterns on X. Okay, so here these different patterns are generated with this for this X. Okay, now this is applied to added to the multiplexer, and then it is applied to the combinational circuit. Okay, so the portion of this test that is applied to the combinational circuit. Again, some portion can be applied through this another sequence generator where we are using a Y bits. Okay, so that is Y test pattern that is again generated differently, and then that is applied to the flip flops and multiplexers. Now, this output of that is applied to SIC, or it could be applied to MIC. Okay, so that means for the combinational circuits output, that is a multiple bit, so that is applied to the MIC. And if this has suppose a shift resistor which is having a single output only, then we can use a SIC, and then we will get Y signature, or we can get Z signature, that is nothing but multiple output. So depending on that, we can get these signatures for this uh, circuit under the test. So this is the approach that is used to apply or implement this built-in self-test. Now let us discuss about built-in logic block observer. Okay, so this uh, as we have discussed that the BIST, that means built-in logic test, that has the internal capability of generation of test. And then after that, we can compress this test pattern using SIC or MIC, depending on the number of inputs that have. So instead of using this separate circuit for these two functions, it is possible to design a single circuit that can serve for both these purposes. That means it will generate a test pattern, as well as it will be used for compressing the results. Okay, so that means for generating signature also we can have a single circuitry, and that is called as a built-in logic block observer. So here this is the circuit that is a structure of, okay, now this is a possible structure. You can you may have a different circuitry for this, but this is the possible circuitry for built-in logic block observer, which is also called as a bilbo, that is a BILBO. Okay, so this is the abbreviation that is used for this built-in logic block observer. Okay, so this circuit, uh, we will discuss about this circuit in the next lecture. Okay, so for um, I hope you have understood this.